The focus of this session will be 3D geometry handling and meshing in HyperMesh, and how we can quickly and efficiently generate solid mesh. Firstly, we will look at the Feature Manager and understand how this combines automatic feature recognition and tabular management to quickly identify and edit or remove particular features. We will then see how users can directly interact with their model to make changes, whether it be geometry creation, editing, or simplification. We will then go on to look at the meshing workflows, depending on the type of mesh we want to produce and that is appropriate for our application. In particular, streamlined tetrahedral meshing tools, interactive hex mesh creation, intuitive solid mapping, and quick extrusion of thin solids. Being able to quickly identify features and then edit or defeature geometry can rapidly accelerate the model build process. HyperMesh offers tools to detect features automatically and then review and manage quickly in a single place. We can simplify and defeature existing geometry or edit and create geometry using our powerful geometry tools directly on our model. Let's take a look at some of these in action. Beginning with our open model, the first thing I'm going to do is open up a saved view called tetra, which I'm going to use to demonstrate the Feature Manager. The Feature Manager can be found in the Geometry ribbon of tools. If we go along, select Features, first thing we will see is a number of search parameters that HyperMesh will use. I'm going to keep the default values, apart from changing the value of maximum radius of fillets to be equal to 30. At the bottom, we can optionally choose to delete any existing features or preserve previously identified features. This is helpful if you're breaking up the model build process and are focusing on individual or small groups of parts before moving to wider assemblies. I'm now going to click Find to execute the search. We should now see the Feature Manager appearing, which I'm going to make slightly smaller and move to the left hand side. If we select a feature, for example fillet 2, we should now see that it is both selected and our model surfaces are coloured by feature, with a legend on the right hand side showing us what features are identified. We have a right click context menu available for these features, so if I right click now, I see I have a number of different options. For example, I could fit to screen. HyperMesh also offers this through a double click shortcut, so if I double click on fillet 5, again it's fitting the screen to that feature. These context menus are feature specific, so if I switch to Holes 3D, right click, I have some different options. For example, I could choose to fill the 3D hole, and in this case it is filled in but kept the hole topology. I'm now going to undo this, switch back to the Holes 3D tab, and instead choose to defeature this time. In this case we haven't retained the topology and we completely defeatured. Again, I'm going to go undo. Exiting from the Feature Manager, we also have the option to access the powerful geometry tools used for both creation but also defeaturing. If we scroll to the right hand side and expand out the defeature tools, we see we have a number of different options. I have automatic views turned on, so in this case my model is automatically coloured by topology. I'm then going to use the holes option and go to the advanced options and ensure that my maximum diameter is set to 20 and click Find. In this case we can now see that it's found one particular hole, the one we were expecting, using those diameter criteria. If I hover my cursor over the red surfaces, I can see a small tick appear. If I now click, we've removed that feature. Again, I'm going to undo this. We offer quick and easy workflows for tetra meshing with methods appropriate to your requirements and meshing standards. The first method is accessing the tetra tool in the mesh ribbon, where we can quickly generate tetra mesh from closed volumes of shell elements or from solid or closed surface geometry. We can also quickly remesh to regenerate and refine particular regions of our models. Our next method is using mesh controls through the browser to automate and streamline our entire meshing process. Controls can be applied for batch meshing, surface meshing, adaptive wrap meshing, volume meshing, and refinement zones. Finally, we can create an automatic representation to fully automate the model building process using the part browser. Let's take a look at the first two of these. I'm now going to show you how we can quickly and efficiently 3D mesh this component, and I've switched back to our previously saved tetra view. As a reminder, we can find the mesh tools up here in the mesh ribbon, and if we go over to the right hand side we can find the 3D mesh group. So if I hit the tetra tool and then expand out this option in the guide bar, we can see we can select components, we can select solids, and we can also select surfaces or elements, provided they form an enclosed volume. If for whatever reason they do not, you can use the geometry tools to repair your model before coming back to the tetra tool. In my case, I'm going to use the solids option, select my solid. We'll see the micro dialog appears where I could enter my desired mesh size and hit mesh. I'm also going to expand out the advanced options here to see more options available. For example, I could change my element size definition. I can also change the size here. I could change the element order, for example. I'm going to go down here and turn on the option layered tetra and ensure the number is set to 2, as I would like 2 layers of tetra elements in the through thickness of my component. Once I've set this, I'm then going to hit mesh. It's now meshing my solid and it's now finished. So I'm going to use escape on my keyboard to escape from the tool. I'm also going to use a view shortcut here where I hit G to just look at only geometry, and again G just to have only mesh. I also have a pre-saved section cut, which if I access it down here and turn it on, I'm going to rotate my model and use the view cube to help me and zoom in, and we can see those 2 layers of tetra elements that we have created. And with that, what I'm now going to do is show how we can perform the meshing process, but this time through mesh controls. So first off, I'm going to turn off my section cut. I'll close that there and use F on my keyboard to fit to screen. And then I'm going to change my entity selector to elements. I won't use the keyboard shortcuts this time. Box select, delete, and then I'm going to use G again to look at my geometry. To access the Mesh Controls browser, if we click up here in the ribbon, and we'll see the browser open on the left hand side. I'm going to use a surface deviation method, so I'm going to right click on surface mesh, create model, surface deviation. Now I'm going to use my surfaces, so I'm going to click that there, and I'm going to expand up the entity editor. So first off I need to select my entities, so I'm going to click this box here, and then I'm going to use the Control A shortcut to select all the surfaces in the modeling window and hit the tick to select them. I'm also going to change a couple of the values here, so I'm going to change the minimum size to 1, to lower the growth rate to 1.1, and I'm also going to change element type to trias. Now I'm going to define some angle-based refinements, so I'm going to go to Create, Refinement, Angle-Based. Again, I'm going to select all my surfaces, again, handy Control A shortcut and tick to select. I'm going to lower the minimum angle limit to 30. I'm going to reduce this refinement size to 1 again. And with that, I'm ready to go. I'm going to go up to hit Surface Mesh, right click, Mesh, and it's now surface meshing for me, and it's already done it. So we're now ready to volume mesh, so we just need another mesh control here. So this time I'm going to right click on volume mesh, create model and tetra. I'm this time going to select my component and give that a tick. Ensure that my core mesher is set to tetra mesh. And then we have a few options here for tetra mesh, so I am going to set my element size limits to be average size, and I'm going to leave that as 5. Again, I'm going to change my growth rate to 1.1, we scroll down, I'm also just going to turn on number of layers and set that to 2. We're ready to go again. This time I'm going to right click on volume mesh, hit mesh, and it should now be completed. And back in my modeling window, I'm going to turn off geometry and I'm going to re-enable our section cut, and we can now see those 2 layers of tetra mesh that we have created. So the advantage of doing it by this method, you can fully automate to get a very nice mesh outcome. Moving on to producing hexahedral and hex-dominant mesh, there's several approaches we could take. Let's discuss 3 common approaches. Firstly, we have a general hex mesh tool that allows us to quickly produce solid mesh from faces or element selections. We have the benefit of being able to interact directly with this mesh as it is created and also add optional guides and targets. We could, for example, use a face as a target as shown here, lines as a guide, faces as a guide, or even surfaces, and we can even use a node path. Next up, we have solid mapping, where we fill mappable volumes with solid elements. Here we can utilize the geometry tools in parallel to feature and partition our solid geometry to ensure we can fill the space with good quality mesh. Thirdly, we have a thin solids tool, which is ideal for sheet parts. These parts characteristically have a much smaller third dimension and are commonly sheet metal. We could choose to produce a mid-mesh, but if your application requires solid elements, we can also create a 2D mesh on a source face and then simply extrude this through the thickness to generate hexahedral or wedge elements. Let's now see an example of the first 2 methods discussed. We're going to start off by looking at the interactive hex meshing, and I've already changed the view to a pre-saved view of this single component. In advance, I also prepared some 2D mesh, which we can see if we change the geometry transparency to 75%. This is what we're going to use to generate the solid mesh. So I'm going to enter the hex tool. As a reminder, we're in the mesh ribbon. As my source, I can select a number of different types. I could select faces, I can select surfaces, I can select elements. I'm going to leave the source as faces. I'm going to select these 2 cylindrical style faces. And at this point, we have the micro dialog. So I can update how I'd like to define my elements, whether it's through a density value or through a size. I'm going to change the size and leave it at 8. And I can drag the arrow in the window and we can see how that will impact the created volume. In this case, I'm going to type in directly the value I require, which is -24. And if I hit play, we'll now see that we've successfully extruded out those 2D surfaces. Next up, I'm going to focus on the cylindrical part, where I'm going to again select 2 sources. We're now going to use guides. As a reminder, we could use lines, we could use node paths, elements, surfaces, or faces, but I'm going to leave it as lines and select this outer line here. However, this time I'm going to use a density value to define it, and I'm going to use a value of 60. If I hit mesh, it now creates that solid mesh. And as a simple check, I'm going to escape from the tool, make sure my entity selector is set to elements, select say an element here, and then use Ctrl-T on my keyboard to select attached, and we're selecting the entire component. We have successfully solid meshed it. So we're now going to move our attention to solid map, and what I'm going to do first is retrieve another saved view called mappable in this case, for this conrod. And also for the first time today, I'm going to change my view controls from automatic to mappable. So what this does is color solids based off whether they are mappable or not. This is defined as where we can clearly define a set of source faces and a single destination face with a drag direction between them. The solid mesh will then follow the shared edges parallel to this drag direction. So the colors shown give us information. If it's green, then it's 3D mappable. If it's yellow, then it's 1D mappable. And if it's orange, then it's currently not mappable. As you can see here, part of this component is already mappable. I prepared it earlier. but this is where we can leverage the geometry tools to quickly partition our component so it's then made up of a subset of mappable solids. To show this now, we're going to go up to the geometry ribbon. Moving over to the right side, we find the split tool. And if I click it now, we'll see I have a number of different options available to us. All of these are useful depending on our geometry, but in this particular case we're going to be using split by plane. I'm going to select the solid as my target, and then I'm going to click on Tool in the guide bar, and if I hover over the solid we can see that it's finding various snap points around my model. I'm going to zoom in and use this flat surface here to help me, and I now see that I have a red preview of the split it's going to make. So if I now hit split, you should be able to see that we've added an extra edge shown in yellow as it's between shared solids. And I'm going to repeat this now here on this other flat surface. I'm going to click on it to use my tool, and by default the tool is smart enough to then automatically populate the target entry as well. So I'm going to hit split again. I've now made those two cuts. So you may be wondering why they haven't changed colour yet, why is they not mappable? And that's down to some of the edges around here. So what we're going to do now is use the suppress tool, zoom in and carefully select one edge, rotate around, select a second edge, and select a third edge, and this top part of the solid is now mappable. I'm going to zoom in here for the other part and go 1, 2, and I'm just going to rotate my model around again, zoom in, and 3, and that's also mappable. So we may be thinking that our view is a little bit cluttered at this point, so in this case I'm going to escape from the tool, make sure my entity selector is set to solids. We could have done that through a keyboard shortcut. Select the remaining unmappable solid and use I on my keyboard to isolate. So the remaining part here is to split, and again by plane, so I'm going to select this solid, click tool, and I'm going to move it over here. And what you see currently is this preview probably doesn't look quite right, but we also have the interactivity in order to change the cut we're making. I can select various points on my model to help define that cut. I'm now going to hit split, and we now see that we've made it fully mappable. So we just need to refetch all of the solids that make up this component, and this is where the entity selection in HyperWorks helps us. So I'm going to change the components, and I'm going to select this solid in front of us, and then I'm going to change back to solids. And we'll see that it's in fact now selected all 9 solids associated with this one component. And then if I use A on my keyboard to show all, we have now refetched all of our solids. So all that remains now is to mesh all of these mappable solids. So I'm going to go back to the mesh ribbon and go along to the 3D mesh group, and this time select solid map. Now we could choose to select all of our source and target faces, but you also have the option to let HyperWorks automatically detect these for us. So what we're going to do is use a box select and select all of our solids. Going to choose a value. I'm going to use 1.5 millimeters, and I'm going to hit mesh. So at this point it's generated the 2D mesh on the source faces, and we could optionally change the density along edges, or the biasing, or even how the faces are mapped, but I'm going to mesh it straight away. You do have the option to disable that as an option, so just go straight from create to fully meshed. However, it does give you that flexibility if you do want to edit those 2D meshes before you fully create your 3D mesh. And there we go, we now have that 3D mesh created. So all that remains to do, I'm going to escape from the tool, and I'm going to again use the G shortcut on my keyboard to toggle to geometry, and then finally to mesh. That brings us to the end of the 3D geometry and meshing session. First off, we looked at the feature manager and how this allows us to detect, review and edit model features in one simple to use table. Next up, we looked at direct geometry editing and how we can create, repair and defeature directly on our models within the modeling window. We then had a look at the tetrahedral meshing workflows and how we can quickly create tetra mesh with optionally using automated controls to speed up the process further. HyperMesh also allows us to interactively create hex mesh, where we can extrapolate 2D mesh interactively with optional guides and targets, such as using geometry surfaces or lines. We then also looked at intuitive solid mapping, where we used the combination of the geometry tools and easy partitioning, and the visualization capability of HyperMesh for mappability. HyperMesh also offers quick extrusion of thin solids, where we generate a 2D mesh and then simply extrude through the thickness.